and I will address a couple of your questions in just about a minute. So if you've got a question, please type it in. If you don't have a question, that's great. Please tell me that. We have 22 in the Pear Deck, in the Zoom, and 20 in the Pear Deck. So make sure you're getting over there, please. Got some really good questions. I hope to address those in a minute. Got some great questions about the quarter project coming in. Keep those coming. Keep those questions coming. We have a pretty full day, so I'm gonna give you about 30 more seconds. Got 23 in the Zoom and 21 in the Pear Deck, so there's a couple of you still not in the Pear Deck. Do your best to get over there and do that for me. I think I got most of your questions, so let's take a look at these questions. So I'm gonna pause you if you're typing. So let me clear my notes here. Okay, can my third TED video be about politics? Your third TED video has to be from the TED Ed website. So if the TED Ed website has a video about politics, then absolutely. But it has to be from the TED Ed website, okay? Because those are gonna be in the scope of things I want you to deal with, okay? So if it's on the TED Ed website, which I've linked for you in the assignment, then you're good to go. If it's something you found on YouTube, then no, okay? Do we have to fill out all 1, 2, and 3 and turn it in today? That's probably going to be difficult to get it all done today for some of you. Some of you, you are all caught up on all your other work and you're just gonna copy and paste from assignment 1 and 2 that we've already done. So there's gonna be some of it you don't need to do that much work on. However, some of you are gonna need to do the whole thing from scratch and that could take a while. So do your best to get it in today, but I'm not gonna count off if you turn it in tomorrow, okay? So I would get as much done as I can and then do the rest tomorrow and this weekend. And we'll talk some more about that in a second when we look at next week's calendar. Conservation of energy homework. So you can send me a private message, this student, and maybe be more specific what part of it you don't understand. In the announcement yesterday, yesterday in the announcements or the day before, I posted a video of the Zoom and I talked through some of the conservation of energy problems. We're also going to look at it today, so I hope that might answer some of your questions. Okay, do we have to do all 3 of the CR this week or are they spread out? Is this the last assignment we have to do for the quarter project? So no, this is baby step number 2. So we did baby step number 1, we picked a video and we kind of wrote about it and looked at some evidence for it. Baby step number 2, we're actually defining what the claim is for our videos, and now we're actually looking for evidence that either fits a definition or fits the claim. So we're getting a lot more specific. Next week, your assignment will be to do TED number 1 and do the final write-up for it. And then the week after, you will have TED number 2 to do the final write-up for it. And then after Thanksgiving, that week we come back, you will do TED number 3, do the final write-up, and then the next week you will have your video. You will pick the best one and make your video of it. So basically there's one thing due every week based on the quarter project. The last day for the quarter project is December 16th, and I'm trying to space it out so that you don't do it all at once, you don't do it all at the last minute, and that you have time to actually put some good thought into it and put some good work into it. So, but for the document for today, yes, I'm going to ask you to do that for all 3. That's going to be a little bit challenging to get it all done today. It's a lot of work, I know, but you're going to have some time next week to work on that as well. All right. So our objective for today. We are going to talk about next week's schedule because next week is going to be a weird week as far as schedule goes. It's also progress reports. Then we're going to review for your quiz for this week. This quiz this week is going to be comprehensive. It's going to cover energy. It's going to cover work. It's going to cover kinetic energy, potential energy, heat, all the vocabulary, all those kinds of things, okay? Including conservation of energy. Then we're going to do kind of a conservation of energy challenge. We're going to explore a drawing, and you're going to basically share with me what you think. And then we're going to spot the imposter. We're going to look at some 7 steps and look for the person who's trying to derail us and make us go the wrong way. All right. And we probably will run out of time, but hopefully we'll have some time to talk specifically about the quarter project, but we need to do the other stuff first. All right, so let's jump into it. Next week, so in your planner, you might want to mark this, but next week on Monday, you're going to have your new, this is the last week we're going to do energy specifically, but waves is how energy is transmitted. So we're going to be talking about waves. So you're going to have new vocabulary. So we're going to start by making vocabulary flashcards and practicing our vocabulary. And you're going to have a video with the basics of waves on Monday. On Tuesday for our Zoom, it's going to be a quarter project / catch-up day. So that's pretty much, you're going to have basically maybe 3 slides for your Pear Deck. It's going to be, hey, welcome to class, get this stuff ready. And then, okay, now you're going to work on your quarter project, but you still have to come to class, okay? Because you still need to get attendance and all that stuff. But it's going to be quarter project and catch-up day. On Wednesday, there's no school. No school on Wednesday. So my plan for that day is for you to do catch-up work. You're going to have an extra day to catch up and work on your quarter project. There's not going to be a new assignment. It's going to be, hey, keep working, keep catching up. On Thursday, we're going to have our first Zoom on waves. So we'll cover the concepts brought up in the video. And then on Friday, you will have a vocab quiz, weekly reflection, but also Friday is progress reports. So your report card for progress reports will be on Friday. Wednesday is November 11th, which is Veterans Day. So usually that day falls on like a Monday, and we just take a Monday off and have like a 3-day weekend, but it fell on a Wednesday, and so it was kind of weird. But yes, it's a holiday. So in the Pear Deck, what do you need to get caught up? What are you going to do to get caught up? If you are caught up, then you need to think about quarter project. What are you doing during that time? So if you're caught up, then you're going to be working on your final write-up for video number 1. All right, type in what you're going to do, and I'm going to help my daughter very quickly, and then we'll move on. All right, good stuff. Wednesday is going to mean you should probably be working on your quarter project, but I am not going to assign anything new. So I'm going to post the assignment for Tuesday, but honestly, it may take you a little bit of time to do it. So, but yeah. Tuesday and Wednesday are going to be primarily for catch up and working on your video number 1 final write-up. All righty, let's get going. Let's move on. Thank you for sharing with me what you're going to work on. Think about it some more. If you know exactly what you need to do, make sure you're making a plan for those 2 days. I already got the plan for the week, so as soon as it's finished, I may even post it early so some of you can start working through it, okay? All right. So now what we're going to do is we're going to have a series of questions using this picture, and you're going to tell me the answer in your Pear Deck. And this one, it's a type in, so you're going to type your response in Pear Deck, but let me overview the story, and then we'll come back and I'll ask the question. So here we have a roller coaster. So we have this car for a roller coaster, and it's going to roll down the hill, okay? At the very top of the hill, we're going to pretend like this roller coaster is not moving at all. In a real roller coaster, usually there's that little machine with the little cable that's pulling you up. okay, somehow. So you're kind of climbing a little bit. There's one or two roller coasters where it'll just freeze you right at the drop and it won't let you drop. And then all of a sudden it will let you go. Okay. But we're going to pretend like we're stopped. We're completely stopped at the top of the hill and then it's going to let us go. Okay. So this first one has a height of 12. This one's halfway, height of 6. And then right here, we're on the ground. And I'm just telling you, without doing the calculation, that the potential energy is 120 joules. So now, here's the question. What is the kinetic energy of the roller coaster before it starts down the hill? So we're only looking up here, only up here. What is K? And what is E? So go ahead and tell me that in the Pear Deck. What is K? You could say kinetic energy. The kinetic energy is, you could use that kind of a sentence, or you could just write K equals and tell me. E equals. But what is K and what is E? Go ahead and type that in the Pear Deck, and then we will share what you've typed. For the K part, you need to ask yourself, what's the test for kinetic energy? Just at the top. We're not worried about halfway or the bottom yet. We'll get to that in a second. Just the top part. All right. I'm going to clear out my drawing here. And let's take a look. I'm going to pause you if you're typing, and we're going to take a look. 0 kinetic energy and 120 total energy, which is also what is said down here. K equals 0 and E equals 120. And those are both absolutely correct. So let's talk about it. Why is K equal to 0? Because I told you it's not moving yet. It's not moving yet. So K has to be 0. So K equals 1/2 mv squared. What's the test for kinetic energy? Does it have velocity? If it has 0 velocity, if V is 0, what's 0 squared? Still 0. What's 0 times m? 0. What's 0 times 1/2? 0. So guess what K is? 0. If it's not moving, K equals 0. So now it's easy. 120 plus 0 equals 120 joules. So that is very, very important. U is at its maximum, K is at 0, and E is equal to U. Okay. Well, let's take a look. We're going to jump down to the bottom here. Let's jump down to the bottom. I'm going to switch screens here. Okay. So now we're down here at the bottom of the hill. What is U, K, and E at the bottom? So remember, up here, K is 0, E is 120. So what is U, K, and E down here at the bottom? And a hint is you might want to start here first. Type that in the Pear Deck for me. What is U, K, and E at the bottom? Very nice, good. A lot of you got this. So I have a student who really doesn't know what the answer is, but they're at least telling me what K and U are. That's important, okay? We've got about 9 of you who haven't typed anything, so let's get something typed in, please. Something typed in, please. Interesting answers. So we got someone saying U equals 0, K equals 120, and E equals 120, and that would be absolutely correct. We are, for being 100% correct, we are missing the joules at the end, okay? So this person says the same thing. And let me switch to my mouse. Okay, so this answer, total energy is 0 and everything else is 0 because it's at the bottom. Okay, so for the story that I've set up, that's not correct, but let's talk about when it would be correct. When would this be the correct answer? Okay, because that's part of the confusion is we're thinking about this as our answer, and we need to know when is that actually the answer and when is it not the answer. Okay, so the correct answer is the total energy is 120. If we have 120 joules for our total energy, The total energy has to be 120 joules. You can't have more energy, you can't have less. We're at the bottom, so the height is 0. It's not off the ground anymore. So there is 0 potential energy. U equals mgh. If h is 0, then the whole thing has to be 0. So guess what? Kinetic energy has to be 120 joules. But let's think about it. Why? Because the cart at the bottom of the hill is moving at its fastest rate. At the bottom of a roller coaster hill, that's when you're going to be moving the fastest you can possibly move. Okay? If it's a straight down roller coaster. Okay? 120 joules is the maximum kinetic energy you could have. Okay, so that's the answer we're going to look for on the test. But let's talk about why everything would be 0. What has to be true for this whole thing to be 0? The car has to like hit a brake and be absolutely still and not be moving. So it's on the ground, it's not moving, so U plus K equals 0. But guess what? E cannot be 0. It has to be 120. Why? Because we started with 120. But that means we have another type of energy that's not present. Okay? So total energy could be Q, which is heat, plus U plus K. Okay? And there's actually another thing we could add. We could add work for non-conservative systems, which has to deal with friction, okay, and types of material. But that's pretty advanced. But if something looks like the energy got destroyed or disappeared, it didn't disappear. It turned into something that we haven't talked about yet, or we don't know what it is, okay? So that's in the skate park physics. If you drop the skater, like it says, drop the skater on the ground, and you saw the U graph, the K graph, and then you saw the heat graph, the Q graph, okay? Then you saw that in your skate park physics. Okay, but in a pure kinetic energy, potential energy system with no friction, you're gonna have U plus K equals 120, U plus K equals 120. Why is it 120? Because I did the calculation already and calculated it for you. So in your homework, I think it was 196 joules was what you wound up being right here. Okay, but I calculated it to be 120 with some information I had. Okay, so U is 0 because it's on the ground, and K has to be maximum, has to be 120. Notice, flip-flop, K is 0, U is 0. K is 120, U is 120. Okay, all right. Questions, drop them in the chats. We're gonna try one more question on this picture. So let's talk about the middle. What is U, K, and E when we're exactly halfway down the hill? Good. I like that some of you are making an attempt, but you're not sure. That's fine. That's excellent. Learning occurs when we make a mistake and then correct it. Because if you don't have to do that, then you didn't learn anything. You just told me what you already knew. It's amazing how learning actually works. Ah, very nice. Excellent explanation. Some of you are just writing the answers, and that is okay, but I've got a couple of you explaining. Great. All right, let's take a look. I'm gonna pause you, take a look. K halfway down is half the kinetic energy. The half U is half the potential energy. So the total energy would be cut in half. So all of that is true. This is, the total energy would still be the maximum. It's just half of it is K and half of it is U. So, and I think that's just a matter of trying to keep the sentence short, but it looked like you were explaining it correctly. Okay, so this one, both K and U are equal. So 120 divided by 2, which is 60. So 60 is kinetic energy, 60 is U, but the total is still 120. So this is an excellent explanation. Let's go back to our drawing and make sure that we all understand what this means, okay? Select the mouse and back to my pen. So if we start with 120, we have to have a total energy of 120 all the way down. The energy we start with has to be the total energy the whole way through, okay? Can't have more, can't have less. Now, if we're halfway down and you actually do the math, which you could have done, I didn't expect you to, but if you did, you would have gotten half of U. We're halfway down, so we got half the potential energy. So the potential 120 divided by 2 is 60, which means how much K must I have? I gotta have the other half. 60 plus 60 equals 120. So what has happened here? We went from not moving till now we're moving faster and faster and faster. So half of the potential energy was converted into kinetic energy, and the other half is still potential energy. And then as we go down here to the bottom, all of it is converted to kinetic energy. Okay, so the total energy never changes, but it starts as potential energy, is half and half, and then at the bottom, it's 0 potential and all kinetic energy. Okay, that's conservation of energy in a nutshell. Okay, this one's a little different. This is you're gonna drag your little, drag the little red icon down here at the bottom, and you're gonna drag it onto the screen, and I'm gonna ask you a series of questions. So the first question, according to this drawing, we have a person pushing a box up a hill, up a ramp, and they push it up to the top, and then it's going to fall and then hit the ground, okay? So in this picture, show me where is work being done. Show me where is work being done. So move your pointer to where the picture best represents work being done. So drag your red marker. Where is work being done? So drag your marker over. Let's see. It's like most of us are telling me it's being done at the bottom where the man is pushing on the box. Okay. Well, let's take a look. So we have the person pushing in this direction. So we have a force and the direction are in the same direction. So we do have work. So right here, yes, we have work being done. Guess what? There's one other place work is being done, and that's from here to here. So in this case, the force is the force of the man pushing on the box, and the distance is going to be up the ramp. So distance of the ramp. But over here, when the box falls, we have the force of gravity pushing it over a distance, which we call the height, and we have work being done. Now this time the work here is creating U, and here the U, work is converting it to K. Okay. So there are actually two places where work is being done. All right, next question. I've already given it away, so let's see if you remember. Where is potential energy at its maximum? According to this drawing, where is U equal to the maximum? Drag your marker, show me where is U at its maximum. Where is U at its maximum? Move that red marker. Where do you think it's maximum? Looks like most of us are going up to the top of the ramp. Some of us haven't moved our mouse yet. Get back over to that Pear Deck screen. And let's see. Yeah, absolutely. That's maximum potential energy. All right, let's change the question. Where is U at its minimum? Where is U equal to 0? There are actually two possible answers. Show me the one that's most obvious. Show me the one that's most obvious. Yes, you got it. You got it. So down here, U, the box, is on the ground. If you see the picture, the box is sitting right here on the ground. U is equal to 0 because it's on the ground. Where would the other place be for the box to have 0 potential energy? Show me the other place. Yes, move it over there. Where's the other place where it would be 0? Now the box would have to be all the way down here at the bottom, but absolutely down here at the bottom. U would also be 0. U would be 0 down here at the bottom of the ramp. Okay, all right, well, let's try another one. Okay, so where is K equal to the maximum? Show me, drag your marker, where is K equal to the maximum? I think there's a little more confusion. Be careful. Where is K at its maximum value? What's the test for K? Where is the box going to be moving with the most speed? So where is the box going to move the fastest in this whole picture? Here, maybe I need to hide the responses for a second. Just look at the picture. Where is, in this picture, where is the box going to be moving the fastest? Going up the ramp or all the way down here right before it hits the ground? Let's take a look. What do you think now? Okay. Some of us either haven't moved our mouse or we're not sure. So let's talk about this one. So first off, as the box is being pushed, is the box moving? Absolutely. So does it have K going up the hill? Yes. Until it reaches the top, there's going to be a split second where the box is not moving. So U is going to be at its max. K is going to equal 0 because it's not moving. But as soon as I let go, now we've got the box moving, so there has to be some K. But where is it going to be moving the fastest? That split second right before it hits the ground. So right before it hits the ground, I mean, if I drop my pencil, when is my pencil moving the fastest? Right before it hits the table or hits the floor, okay? So K max is right here, just before it hits the ground, okay? The maximum K is right there, just before it hits the ground. Now, once it hits the ground, it's not moving anymore, then K equals 0. But all of that energy is not lost. It turns into heat in the floor. The floor now absorbs all that energy and it turns into heat. Okay? All right. Let's go and questions. That would be thermal energy. Q is the change of energy into thermal energy. If you really drop something heavy on a floor, if you feel the floor where you dropped it, you can actually feel the heat in the floor. The floor will feel hotter. But for us to tell it with just by touching it, it has to be a pretty heavy object. Okay. All right, so this is a different type of question. Drag your cursor to which one of these drawings tells the best story that would help you solve the problem the best. So basically, here's the story. I've got an object that I'm holding 24 meters high, and I'm going to drop it. It has a mass of 12 kilograms. What is U? So drag your cursor over. Which one is the best drawing or setup for a 7-step problem? Which one is the best? The one on the left, the one in the middle, or the one on the right? Look at them carefully. Which one is the best to solve the problem? Okay, let's take a look. So far, this is what people are saying. Anybody going to change their mind? Are we all going to sit there on the right? If I talk long enough, I could convince you all to choose something different and you would be wrong. But because I'm tricky like that. So the one on the right is the best one. So let's take a look at why is the one on the right the best one. Okay. So this one over here is the best one. Why? So as I'm drawing this, as soon as I see something is going in the downward direction, I automatically know that there's gravity involved. Okay, so none of these other problems mention gravity. So that's one of the reasons this one is the best one. The other reason is it actually gives us our given and it has all the variables. Now, we haven't done a whole lot of these because we just don't have time, but sometimes you'll have an object moving left or right. And so gravity is still at work, but the ground is pushing back. And so those two forces actually cancel each other out. And so generally gravity is not a factor if it's left to right. But as soon as it's going down, gravity is a factor. And so I know I've got to write the little g. Okay? So that's why this one is the best one. All right. Pretty simple, that one. Most of us got it. Let's take a look at another one. Oh, do I? No, that was it. Okay. So in this one's a little more challenging. This is a writing problem, so you can draw on the slide. But at the bottom, you should also be able, I think it's at the bottom. Correct me if I'm wrong. Share it with me in the chat if I'm wrong. But down here, you should also be able to select a text box. You click the text box, you click on the screen, and you should be able to type your equation. M equals or U equals, okay? So you've got your givens list, you've got your unknown. What equations should you write? And guess what? You can use your equation sheets, but there are also only like 4 equations we've been using. You've got U equals mgh, K equals 1/2 mv squared, work equals force times distance, and power equals work divided by time. Those are your only choices. We are so spring-loaded to just solve the problem, but that's not what I want you to do. I want you to write the correct equation. Write the correct equation, and I want you to write the root equation. I see some people trying to derive the equation, and you are not correct. Some of you. Nope. Close. What is the base equation? I see someone's thinking by what you're typing, and I love what you're thinking. And we are definitely going to be talking about it. Oh, so close. So close. I love this. This is good. I'm seeing mistakes, and we get to talk about them so that we can learn. Because you only learn when you make a mistake. Good stuff. We're going to get to learn here. Somebody's been plugging in just numbers. That's not what I want. I want just the equation. Actually, okay. The person who has written only numbers, don't change your answer. I'm gonna use what you wrote to show people something. Okay? Don't change what you did. I don't know. That's okay. We are going to talk about the middle one for sure. Okay. The first one and the last one are pretty straightforward. Most of you got that one. All right, let's take a look. I'm going to pause you for a second and let's look at some possible answers here. We'll come back to that one. So here is the correct answer. We've got U equals mgh. So we've got our unknown is U, and the equation for potential energy is mgh. So as soon as I see that, I'm automatically thinking mgh. This one over here, yes, we are looking for H, but as soon as I see U and mg, I'm still thinking U equals MGH. That's what I have. I have U, I have M, I have G, and I have H. So that's the equation. Now, we are looking for H, so I'm going to have to do some algebra, which is going to mean we are going to divide in this case. Sometimes we don't, so be careful. You don't always do division first. 99% of the time you do, but not always, okay? And then this one we have force and distance, and this is work. This is not power. This is work, okay? Why? If it's W by itself, it's work. For it to be power, for it to be watts, it has to have a number in front. So it's only watts if it's got a number in front. So this is 100 watts, okay? So if W is after a number, it's watts. If it's by itself, then it is work. All right, so let's go and take a look at, so that's what this person did, is they saw the W and were thinking power. So, and if it was power, power is still work divided by time, okay? But we don't have a P. There is no P up here, and there is no time up here. So that's how we know it can't be that one. There's no power. There is no time. There's only work. Okay. This can be confusing because we have done some two-step problems where you have to calculate the work and then calculate the next thing. But notice what's missing in this table. There is no time, so it would be impossible to solve this equation. We are missing the variable of time in our table, so that power would be impossible to find without more information. Okay, because T is missing. All right, and I've already talked about this one. Because it's H, we've taught you how to look for an equation that's like that, but the actual equation is U equals MGH. Which, if you substitute properly, like this person did, substituted properly, you have H by itself, so you would multiply these numbers, and whatever that number is, I'm rounding here, would be approximately 150 times H. Then you would divide both sides by 150, and you would actually wind up with the answer. Okay? And that's basically what you would get. It's actually a decimal because I rounded here. I didn't do the full math. Okay? All righty. Let's try another one of these. Okay, here's some new problems. Write the equations for these. Just the equation. And the third one is a trick question, so be careful. What's the base equation? Don't do a derivation. Some of you are using the triangle, I think. I want to see the root equation. Some of you have written the correct derivation, but I have no idea how you got it. I need to see the root equation. So the person last time who put and then divide for the last problem, be careful. And this time you're actually not going to divide first for the middle problem. Okay. Someone's trying to do the derivation, but there are two different equations. You've got the wrong equation written for one of your two power problems. Let's take a look. I'm gonna pause you. Let's take a look at what some people are putting. So this one is absolutely correct. So let's start here and then we'll talk about a couple of the mistakes that I'm seeing. So we've got power, we've got work, and we've got time. As soon as I see that, the equation has to be power equals work divided by time. Now, if you're handwriting it, you should definitely write it as a fraction. The only reason this is acceptable is because you are typing it, and I said that that's okay. Now look at this one. we still have power, we still have work, and we still have time. So guess what? The equation is the same. But when you plug in the numbers, you're going to have to do algebra, okay? So if I did plug in the numbers, I would get 32, because that's a power, so it goes in for the power, equals, what's work? Well, work is question mark, so we have to put the W, and then the T is 12. So instead of dividing first, we're actually going to multiply both sides times 12. So 12 divided by 12 equals 1. 1 times W equals W. And W equals 12 times 32, which is, what is that, 360, 384? Okay, 384. We're doing work, so it has to be joules. Okay, so be careful, because this is work and this is power. Notice this W is after a number, so this is watts. This is W is by itself, so it has to be work. Okay, I'm going to show you what somebody else wrote that is actually, I would consider wrong, because you didn't show me your algebra, and then we'll, just so I can be clear on that. But this is what you should write for your power equation. All right, let's talk about this last one real quick, and then I will go and show what some other people are doing. U equals MGH. Why? MGH right there. Guess what? That tells me I'm probably going to have to use the U. But I'm looking for V. Does MGH have V in it? No. So I have to have another equation. Well, the other equation that has V is this one. Oh, but it's V squared. Don't forget the squared for the V. 1/2 M times V squared. Okay, but what's K? Well, U at the top of the hill that we've been talking about is equal to K at the bottom. U equals K. So when I find this answer, I'm going to plug it into here. I have M, so M is going to go into here. And then I just do algebra, and I do my algebra, and then I have my V squared, and then I do my square root of both sides, and then I get my V equals something. Okay? That's the problem we worked on Tuesday in class. So be careful, because it has MGH and then it has V. So you have to use both equations. Okay. Let's look at what somebody else put, just because I see too many people doing this, and we need to talk about it. So first off, this one is just straight up not the one we're going to use. Now, this one might get you the right answer, but I would count off a point, because it's not the base equation. The base equation is power equals work divided by time. Now, some of you sometime in your career, I think you were taught the triangle. So you were taught power equals work divided by time. And so now I'm looking for work. So that equation is actually wrong. It should be work equals power times time. That's a P. Because work equals power times time. And that would actually be the correct equation. But if you're doing the triangle, I expect to see the base equation, I expect to see the triangle, and then I expect to see the equation you pull out of it. Because then I can give you credit for your thinking. Okay? So that's power times time. But you got to be careful, because if you're using the triangle, side by side means multiply. It's only if it's up and down that you got a division. And if you don't know what I'm talking about and you want to learn the triangle, you can come to tutorials. Otherwise, our equation is always power equals work divided by time. Plug in your numbers and then do your algebra. That's really the way I want you to do it, because it is the high school way. But if you need to use the triangle, you got to show the triangle. Because I'm all about you using helping tools that you've learned in the past, but you got to use it correctly. All right, questions on that? Questions on that? Okay. Oh, wow. That took us way a lot of time. All right. Doing a lot more explaining this time. Okay, we're going to do this and then we'll be done for class time, but we need to go ahead and take a look at this. So the boxes in green, I've worked the 7-step problem. I've worked it all the way to the end. So I've got the equation written. I've got my substitute. So what's in green is correct. But what's not in green, there is a mistake. So what is not in green, there's been a mistake. So what I would like you to do is number 1, number 2, and number 3 is spot the mistake for me. If you can do that really quickly. As a minimum, see if you can tell me what's wrong with number 1, and because you may not have time because we're going to move on pretty quickly. Number 1, what is the mistake for number 1? What did they do wrong with number 1? So here is the answer because we're almost out of time. They divided by h. That's not correct. That's not correct. Because if they divide by h, the h will cancel, and then they will have 30 divided by h equals 49. Well, that didn't help us. That only made things worse. Okay? So what they should have done is divided by, so we've got our h still here. They should have divided both sides by 49. Turn that h into a 4. 49. And now the second mistake is they didn't do their math with the number right. We multiplied instead of dividing. So that was the second mistake. Okay? The mistake here is this is multiply, but they divided instead, so they should have multiplied. And the mistake on this one is they did their calculator wrong. You get so used to using a graphing calculator that it just does things right for you. So you type 30 divided by 6, and you should get the answer of power equals 5 watts. That's the correct answer. But this one, what did they do? They actually did 6 divided by 30. If you're using an old school calculator, that's really easy because you're using this little divide button, and a lot of us don't know which order to put that button in. So somebody probably put 6 divide button and then 30. They did the numbers backwards, and so they got 0.2. That was an actual mistake from your homework. Okay, so we are pretty much out of time. So here's what I want you to do before you leave today. There are actually a couple more of these that you can go back when it's student paced and look at on your own. But what is your main takeaway from today? So not from the homework, although you could tell me that. What is your main takeaway from today? And if you have any questions, you can drop that in chat. Once you've got this question answered, you can take off. And I will see you on Tuesday of next week or during tutorials, today or tomorrow. But get this answered. Pear Deck is turning student paced right now. Bye. See ya.